Alright, so here is my function generator and my oscilloscope for the engineering class project. It's all in LabVIEW. Let's fire it up. So there we got our sine wave, got our voltage information over here on the panel. I love this digital readout look. Peak-to-peak volts if you need it. Here's your frequency right here, so that's probably the most important, is your actual readout of frequency. You can switch between square, sine, triangle, and saw functions, so whatever you need to do there. You can raise the amplitude. We'll go up to 10 volts basically. Frequency, so I can increase this frequency. This is just 0 to 10 frequency increase, and you can see here, this is our multiplier, so if you just want, 10 hertz, then there's your 10 hertz. If you want, around 60 hertz for household voltage measurement, you can get it in there. This will go up to 20 kilohertz. Yeah, really beautiful there. A lot of information. I'm going to tone it back down so it looks better. There we go. And then, there we go. And then over here, you can turn the noise on and off. So if you want some noise, we got gamma, we got Bernoulli, Gaussian, and uniform white. I like that gamma noise. That looks cool. You can turn on a filter, basically an oscilloscope control to filter that information out. And then you have a high pass and a low pass. And then here you can cut off at a certain frequency. So if you want to filter a certain band out, then you can do that. Turn all that stuff off. And here's your volts per division, so you can change your y-axis basically. So if your amplitude's a little high, you just increase this. There we go. Now you can see the full waveform again. Over here is your x-axis controls your milliseconds per division. So if I wanted to take a look at more or less on here, I could. I put a time delay in here because sometimes it's, depending on what value input for frequency, it looked like it was standing still, so it looked like, is the thing even running? So instead of going into the block diagram and changing the time delay all the time, I just created a control for it. So, and that actually is pretty useful, so I like that. Anyways, so over here you can capture. Here's the gate trigger, so we can just freeze that puppy. I'm going to capture a screenshot, and it just automatically asks you, hey, where do you want to place it? What do you want to name it? So I don't know. Just stick on my desktop. There we go. If I hit write to a file, automatically writes to a file that I specified a name for. That is this LabVIEW measurement data function LVM. So we can see that. And we're on the waveform right now, so if we go up here, there's our Fourier transform if you need that. Turn off the gate. There we go. Yeah, it looks cool. And yeah, I think that's about it for the controls here. As far as the code, then you can see it all here. And yeah, here's our bread and butter. That's our signal out. And it's just a kind of a case within a case structure, all depending on what you choose for your dials. Here's our select statement, so you can switch between your regular signal and your noisy signal. And then that signal out, and this is everything we do to it. We take our spectral analysis here. Here's our filtering, tone measurements. Yeah, everything you could ever want, I guess. Here's our filter switching. Here's a waveform mount. I just put that in there for fun. Yeah, so this is the whole thing. If you have any questions, just send me a message, let me know. And yeah, it was a really big, really cool project, and had a lot of fun. I guess I'll see you guys later.